Pre-lecture video 1, Units and Conversion Factors. When someone asks how tall I am, I generally respond by saying that I'm 5'10". You probably understand what I mean, but in scientific terms that's not specific enough to convey information to others. For example, if I had said that I am 70 or 178, you would have been confused. To be accurate, we need to include units along with numeric measurements, such as 5 feet 10 inches, 70 inches, or 178 centimeters. When we write numbers in chemistry, we use symbols or abbreviations for the units. Remember, units are needed when you show your work and when you show your answer in order to justify your calculations. So, what happens if you don't show your units? One famous incident from 1998 occurred with the NASA Mars Climate Orbiter, which was designed to orbit Mars and help us study the weather there. Lockheed Martin, which built the satellite, specified the thrust in pounds, but NASA scientists assumed that the thrust had been reported in newtons. The blue path shows the estimated trajectory for the orbiter, but because scientists and engineers did not include the units, the orbiter did not have as much thrust and ended up on a trajectory too close to the planet, eventually crashing into the planet. This resulted in a huge loss of money and potentially valuable information. The moral of the story? Label your units in all of your work. How should we be indicating units? The Accepted International System of Units, or SI, defines a basic set of units. The measurements we will be using most often, mass, length, time, temperature, and amount, are included in this table. Note that while there are names that we pronounce with these units, we generally represent these units in shorthand symbols in writing. So, kilogram is represented by lowercase kg. Meter is represented as lowercase m, and Kelvin is represented in capital K. It is important that you memorize the unit symbols and their capital and lowercase letters, as we will often add prefixes that will complicate the symbol. Using these base SI units, we can also form derived units, such as volume and energy, which are defined in terms of base SI units. Remember the NASA Mars Orbiter? Its thrust was a measurement of force, which is typically measured in newtons, or kilograms times meters divided by seconds squared. Another possible force unit is the pound, which is based off the English system. Typically, we will be using the metric system in chemistry, and we will regularly see measurements of density, energy, and volume. One important reason for labeling units is to physically show the conversion of one measurement to its equivalent measurement in a different set of units. If we have an equation, we can use both sides of the equation to form a fraction called a conversion factor. For example, since we know that 1 inch is equal to 1 inch, we can create a fraction with the left side of the equation in the numerator, or with the right side of the equation in the numerator. Note that either of these expressions is equal to 1 since any number divided by itself equals 1. This is a trivial case, but other conversion factors are useful because they allow us to change from one set of units to another set of units. We can apply the same principle to equalities between metric and English units, such as 1 inch equals 2.54 centimeters. As with the example on the left, we can create two conversion factors, 1 inch over 2.54 centimeters, or 2.54 centimeters over 1 inch, that represent the same length but just in different units. Once the right conversion factors are established, we can use these in calculations to derive the desired units from a problem, all while keeping track of our changes in our units in a methodic process.